Hi, I'm Toby K. This is a tutorial for V4 Gamma. Today we're going to go a little deeper into the topic of collections. If you've used V4 for a little while, you would know about spreads. We're going to go a few steps further. Alright, so what's a collection? Collection is just a collection of stuff, isn't it? Data structure that groups elements. A spread you'd already be familiar with, but there's also dictionaries and hash sets. We'll go into those. You might run into some more esoteric collections if you're using .NET libraries from NuGet that are not wrapped for VL, like mutable array, mutable linked list perhaps, all sorts of beautiful and strange collections. So, if I create new collections, you'll see they start grayed out because all we've defined so far is that we want a collection, we want the spread structure, but we haven't said what type should be in it, and it can't compile and turn solid until it knows what type is in it. A few ways to set this type. One is I can create an IO box, so if I middle click there and say I want to float, then it knows that is, you can see spread, and then in the angle brackets float 32, and I can do that for anything. It can be a color, for example. And by now you've probably also seen that if I middle click here, I can type it. I can type spread int 32. Fantastic. Dictionary, bit of a special case. You'll notice it has two types, which is the key and the value. We'll cover exactly what those are later. I only want to add right now that if you're manually typing it, this case you use a comma if you've never done that before. So I have to specify both types. In this case, I want a key of type string, which is the first entry, and I want a value of type float. And so that's how you type a dictionary. The last way you might see it done is when you're creating from the double right click in the IO box, there's a spread option here. You click that once and then you click the type you want. And there's IO box of spread with float 32. It's also possible to type a collection with a custom data type. If we make a record here, call it my record. I won't even put anything in that right now, but just to show. And then I can create, or I can even type it up here, spread, and change that to my record. And now we have a spread of my record. Last thing of note is that it's possible to create a collection of collections. I delete that, it's going to freak you out. That's fine. I can actually type spread, float 32. So that's a spread of spreads that contain float 32s. This is something that sometimes happens if you've got to get out of a few for each loops. You'll end up creating this kind of type anyway. Once that gets a few layers deep, it's pretty unwieldy and you maybe want to use a custom type or a different data structure. But spread of spread is not that uncommon. You might need to do that now and then. An important conceptual property of collections is that they can be empty. And this is a difference between collections and single objects. Let's demonstrate that. If I create a text node, the one from Skia that's meant to draw us a bit of text on a Skia layer, you'll notice it has some input pins, but they've all got some data. Even this paint one, we can't really see, set that conveniently. So we have to go like set color, for example, plug that in there. You'll notice set color has a color input and that already has a color in it. I can change it, but it already has some data in it. And V4 generally is putting those single instances where they're needed. There is another state that single instances of objects can have, which is null. I can kind of force that. Null is generally an error and lots of functions aren't ready to accept null objects. They ask for an object and they expect a single instance of an object. An empty collection, sometimes that's an error in the context of your application, but often that's a legitimate way to say to something downstream, I don't want you to do anything. So, for example, if we say we want several texts here, we're going to use a group spectral so that we can see them all with Skia. So spread of layers there, go into the group, and then we see one layer. Not seeing anything though, because this for each is running 0 times, because it's not operating on any collection right now. In this case, fastest way, let's just spread the position there. If we middle click and say I want 3 here, then give us some values, and we see that there's 3. If I make that 2 or 1 again, you can guess what's going to happen. But if I make it 0, we get none, of course. But note, this isn't an error. I could legitimately be saying to this component, I want you to draw 0 things. There's no request to draw anything. It's an important distinction. An empty collection can mean something. One more example where empty collections could be interesting. So let's do a little serialization here and say we want to take this data, which is the empty spread, and serialize it. And we get a string, looks like that, saying spread slash, which actually means it created a spread, but then it's immediately closing that spread. There's nothing in it. You can see the difference. If I put one item in it, you get spread, open tag. There's the item with its own closing tag, and then a close tag for the spread. With 0, you just get that. Say we wanted to send this data and sync another instance of this application over the network. We might have this spread connected to a for each loop that's got something that's preparing packets that's then going to like a UDP sender. In this case, the for each loop is never going to execute. So therefore, nothing is going to be sent over the network. That would be very different to sending this serialized data, which says, yeah, there's a spread there, it's empty. So again, everything always depends on context. It could be very powerful for you that collections can be empty. It might also be an error state. You've just got to keep an eye on it. Okay, so you should already be familiar with the good old spread. Spread is actually a little bit fancy compared to some of the more low-level collection types you'll find in .NET. Spread can do a few things. First thing it can do is that you can enumerate it, and this is actually the very common behavior. Whoops. Let's create a spread of float 32, and then we go for each and connect that there. And then what the for each loop doing is enumerating it. It's going through every item in the spread, and if we have 3, then it's going to run it 3 times and give us 3 results. This enumeration that it can go through the list, that's a property of a collection. And I think all the collections have that. That's the common one. We'll talk about that in a minute. Okay, next property of spread, and I know this isn't going to impress you that much, but it's actually something we can't take for granted, which is that you can get values by index. So other collections don't necessarily do this. Dictionary, for example, doesn't do this. Hashset doesn't do this. Yeah, then we put in our index and we get our single instance out. The next little trick spread can do, which is quite fancy indeed, is that when you take the index above the maximum count, it wraps around. And instead of getting an error, yeah, you start from the start again. That is in contrast to, for example, if I use the get item of plain old array here, and I'll use middle click to create, even though that has the spread interface, it's giving me an array. You'll see as soon as there's 0 items in that array, straight away I'm getting an index out of range exception. I can put 2 items in there, but if I want to access the index 2, I'll also get this index out of range exception. From a programming purist point of view, you might prefer getting an exception because this behavior with the wraparound might be actually giving you data that's completely wrong. This at least stops your application. This might be actually a really critical error that you need to address as the programmer. However, mostly in the v4 context, we prefer this behavior, and sometimes it's very useful. If one was to look in the grey book, you would find an interesting piece of information that says the base type for collections in VL is the sequence, and it corresponds to what is known as IEnumerable in the .NET world. And if you look around, you will see often references to IEnumerable. If we look at the .NET documentation for collections, it says every collection can be enumerated to access each element in order. What is very interesting for us is that anytime you're wrapping some .NET library and you end up dealing with different kinds of collections, for example, let's just get ourselves a mutable array here. If I do this, it should be a mutable array of float 32s. You don't like it, but that's okay. Now we've got it. There's our mutable array. We want to turn that into a spread. That means we can always use from sequence of the spread type because the mutable array also belongs to the sequence type. The other thing this means is that every single collection type can be processed with the for each loop if you put it on the splicer there. Now, if you run it through the other splicer, note that it's turned into a spread. So if I wanted to keep it as that collection type, I would need to do something in the loop that is adding items to that collection or mutating that collection. Let's have a closer look at dictionaries. You may have already seen on the V4 TV channel, there's a great video going over the basics of how to use them. We'll cover that and go a little bit deeper. So a dictionary is a collection that has two generic types. If we just bring up the add operation like we did before, you can see there's a key and a value, and both of those can be any types and they can be different types from each other. Very typically the key is a string, maybe an integer. The value though could have any type, including custom types. The use case of the dictionary is that you can look up data very fast by the key. Even if the dictionary is quite big, it's still a very fast operation, and retrieve that data. But there's a drawback, which is that the dictionary is not in order. It doesn't know the order you save the things in. It doesn't remember the order that's the alphabetical order of the key, for example, or the numeric order of the value or anything like that. The order you get things back is not actually randomized. It's according to a hash, but effectively you don't have control of it if you enumerate that dictionary or you list using one of the other functions to get data out of the dictionary in a list. Let's dive deep. So just to make the comparison, if I had a spread of strings, spread string, here we go. So 5 of those, A, B, C, D, E. I mean, that is in an order for us, which is very nice. And that corresponded to, a spread of 5 integers I wanted to look up. Also, to be terribly convenient, we'll make that 0, 1, 2, 3, 4. If that was representing a key value pair and all I had to work with was spreads, then, and this is how I would have sort of done something like this in V4 beta, what I can do is a for each loop, and I can say when that string item equals, say, C, then I want you to break the loop. And then the result I should get if I put an accumulator here should be the one we've got. But in order to do that, it had to iterate a certain number of times. And if I look at the last reported index, I should see, that was iterated a certain number of times. So to be clear, on the left side, what's happening with this kind of search through a spread every item to find the item you're looking for is the longer the spread is, potentially the more performance we're going to spend searching. The advantage of the dictionary is that it can look up data in basically one operation internally. So while this will have to go at least 5 times, this is going to give you the result straight away. Even if if the list gets longer, the data gets bigger, the dictionary still remains just as fast for doing the lookups. That's the use case for dictionary. It's also simpler UX for you as a programmer. Here I've got 2 spreads or maybe even more bits of data that I have to keep synced, though you could use data types. Dictionary, it's just a bit simpler. You've got this concept of key and this concept of value, which makes that an easier abstraction and paradigm to work with. Okay, let's look a little closer at the way the dictionary actually works, and then we'll talk about what's behind it. So let's look at adding to the dictionary. We'll need a pad. Let's call it dictionary. And that'll need to be above and below. Before I do that, I'll turn the apply on for this and then make sure we only apply on bang. Otherwise, we'll be adding every frame. Put a dictionary above and below. If we mouse over, we can see the dictionary is empty. And if we press add or apply, then you'll see it runs the add operation. And there we are. You can see that value, text with a value of 0. All right, what happens if we hit add a second time? If the value is exactly the same, the key and the value are the same, actually nothing happens. If, let's actually make this apply a toggle so we can see what's going to happen properly. If I make that so the value is different, the key stays the same, I hit apply, I'm going to get an exception here, which is that the same key already exists with a different value. It's not automatically doing anything for me, like overriding, and in fact it stopped running so I can't see the data. It doesn't automatically override or replace or anything like that. So with a dictionary, you have to code what should happen in those situations yourself, but it's usually pretty easy. So if we use dictionary contains key, and we run that first, contains key is going to give us a Boolean if this key is indeed already in the dictionary. It is, and then based on what we want to happen, we could either say don't run the apply, in which case we would simply do and not apply. That must not be true. And then we're not going to get an error because it's not going to run it because the key is already in there. Alternatively, if what we want to do is update the item in the dictionary, don't need that, we turn this add into dictionary set item, connect the apply again as a bang. So dictionary currently just has text 0 in it, and say we want text to be 2, hit that apply, there it is. Set item, we don't need the check because you might think, okay, we'll have the check, and if it's not in there, we'll add, and if it is in there, we'll set. Set item will also do the add. So if we have a new key, hit apply, it's not in there, it adds it. So set item also takes care of that. Okay, removing values, not rocket science. You can see where this is going. We go dictionary, remove, and we will be able to, again, let's get an apply on this before we go crazy and make sure the apply is not locked on. We do this and we connect it to a key. Let's say text2. Let's have a look here. Oh, will it give me a nice print there? There we go. We want to remove text2, hit apply, and it's gone. What's really powerful about that, if you've been using the old spread method of looking after data, is that if everything in your patch is referring to an index, because data is held in a spread and you're retrieving it via index, when you remove an item somewhere in the middle, it might mean indexes above that have to be updated. It's a real pain in the butt. Dictionaries are a much better way to handle a data source where things will get removed dynamically. You can use different data types as keys in a dictionary. However, strings make a lot of sense because you can keep them meaningful. If you're using strings as keys, bear in mind that they are case sensitive. Small tip, if you want them to be case insensitive, there is a function called toLower. And if I put capital A, lower B, lower C, there's are indeed all lower. There's another one called trim. Trim removes white space from the start and end of a string. So if I put a space there, you'll see those spaces. If I hover over there, those spaces are in the string, and at the bottom, the spaces are removed. That's really useful if, for example, you're taking input data from a user that should be matched to a dictionary key. You need to do that both on when the keys are created and also when the user looks them up. But it means, yeah, those kind of entry errors will be ignored. On the other hand, doing this is going to use a little bit of performance. So if you're adding thousands of entries to a dictionary or it's only internal access, there's no chance of user entry error, then you may want to skip it. There's a few more things we often do with dictionaries. For example, clear them, which we can do with dictionary clear. I'll put apply and a bang on it. And mouse over here, you can see there was data, and if I hit apply, the dictionary is empty. Amazing. Okay, so now how do we get data out of the dictionary? Let's move that over here. Let's go try get value. We'll just use a copy of the pad up here. Try get value, and that should tell us if it got the value and what the value is, because we could put a key like that and it's empty, and if I put text2, that's going to give us no result because we cleared the dictionary before. But if I apply, there's text2. If I make that 4 and reset it, yeah, there we got it. Another way we can get values out of the dictionary, if we want to get all the values, is dictionary values, which will read out all the values, and there's also one like that for keys. It'll read them out as a sequence, or we can easily convert that into a spread. Another way that we can get data out of the dictionary is via the IEnumerable interface, but it basically means what we were saying before is that all the collections inherit from type sequence, which means we can use for each on them. And if we do that, we'll see that the dictionary can be enumerated, but in this case, we don't get a string or a float, we get a key value pair. And to do something with that, we need to use key value pair split. and then you get the key and the value. Let's clear this dictionary and demonstrate one last point, which is the dictionary's weakness, drawback, is that things are not in order. So if we do A4, B5, C6, you'll see C ended up getting inserted first. And we don't have control over that order that things will get added. When what you need is a dictionary, but it does maintain some kind of order to the values, then in the nose browser, with the advanced aspect on, there is a sorted dictionary, and that will be able to keep things in an order. However, note it's not as fast as this dictionary. You're getting kind of a compromise. Finally, the dictionary is very fast at getting values, but it's a bit slower at setting values than adding items to a spread. The reason for that is it has to calculate a hash, and we'll talk about that right now. All right, champions, let's talk about Hashsets. And if I sound excited, it's because I am. Hashsets are just that clever. There's a lot of great videos out there about Hashsets. I'm going to put one in the description by a guy called Brandan Jones. You'll learn some things. His follow-up videos to that are really good as well. Highly recommend watching that. We're going to look at the practical use case for Hashsets in v4. Hashsets basically work the same as the keys in the dictionary we were looking at before, same guts inside. The use case of Hashsets is whenever you need a collection that can only have an item in it exactly once. Let's make up a little use case here. Say it's a video game, you're running around picking up colored keys, there's multiple red keys in the level. If you run across another red key, you get the little sound, your score goes up, but we don't want the red key added to the inventory twice. So we want a way that it's going to check what's in the inventory, and if there's already a red key, it does nothing. It doesn't add it. Let's look at the way we do that if we only had access to spreads. So make a little pad, spread, inventory. Another one here, and then we'll do an if region with a bang, and we're going to go spread, add. It's going to be here. And it's going to be string red key. Now, if I keep banging that right now, it's just going to keep adding it. So we also need to do a check. And this is, you'll start to see this looks like the same as before. How do I check the spread for each item? So now when I do the bang, I need another if region here. I could have used an apply, but anyway. Need another if region. So now, oops, we search for red key in the dictionary. That has to go there, actually. Not in the dictionary, in the inventory spread. And if we find it, then in this case we don't proceed. So if we find it, we break. If we don't break, because we didn't find it, then we can trigger the add operation. Whoops. Come on. There we go. And so this should work. Let's just display our result here. No, not that way. Add red key, and if I bang that again, it's not adding red key again because it already exists. We can try and add blue key. That exists. We can add yellow key. No matter how many times we bang it, we only add one. So we've made that same functionality here, just with a spread. The problem with doing it this way is the same problem we had before. The bigger this inventory gets, the longer time it might have to spend searching to find it. The hash set gives us both a better usability as a programmer for doing this, as well as it's faster at doing the lookup to see if the thing has already collided with the hash set. Already collided with an existing element in the hash set, I should say. Let's try this. Item, condition, add. Oops, I think that was on before. So yellow key is already in there. And if I add it a bunch of times, nothing happens. Also don't get an error because this is kind of the purpose of hash set. red key. There you go. You can see Hashset works quite similar to Dictionary. Hashset also has clear, it has remove. One thing Hashset doesn't have is values, but you can straight away just enumerate the Hashset with a for each loop. It has the same drawback as Dictionary, which is that the order of this isn't guaranteed. If I had A, it's not necessarily in alphabetical order or any kind of order. You have to watch that video to understand how the hashes are generated, to understand the order things do actually end up in, but it's one of the main compromises with hash sets and with Hashset-based data structures. Thanks for your patience. Last couple of points to make regarding mutability and collections. Generally, in V4 Gamma, immutable collections will have a plain name like spread, dictionary, hashset. And generally, mutable collections will specifically say either mutable or builder in their name. Of course, there's always the possibility, if you're working with external libraries, that they have collection types that do not follow these conventions. So check their documentation. The difference between the builder mutable collections and the regular ones is the builders are intended for a use case where you're going to turn them into immutable. And the spread builder has a toSpread, dictionary builder and hashset builder both have a toImmutable operations intended for that. For the use case to that, see my other video on mutability. The final point I want to make is that the mutability of the collection does not affect the mutability of the items inside. You can have immutable collections of mutable objects, so pointing to references. You can have mutable collections of immutable objects, so pointing to data, and also vice versa. Mix it up and have a great time. You can find out more about that in the video on mutability. I'll drop the link in the description below. Thanks so much for all your focus and attention. Hope this has been useful. See you soon.